everyone, welcome to Pepcoding. So in this video we are going to start the next question of our tree series, okay? And the name of the question is convert binary search tree to a doubly linked list, okay? So a binary search tree is given to us and we have to convert it in a sorted circular doubly linked list. So we all know that what is doubly linked list, right? So we'll not discuss about the doubly linked list here, but we'll try to convert this BST into the doubly linked list, okay? So let us go to the board and I'll tell you some more information that is given in this question, and with the help of that we will try to convert this BST into a doubly linked list. Okay, so let us move into the board. Okay, so it is a BST given to us. Okay, it is a BST given to us, and what we have to do, we have to convert this BST to our doubly linked list. Okay, we have to convert this to doubly linked list. So how we are going to do this? So for this, the information that is given is, see, there is a tree node, right? It is a tree, so it contains tree node. It is a tree node. So suppose this tree node has a left, right? It has a left, it has a right. Okay, but in a list node, that is the node in a linked list, contains in a doubly linked list. Let us say doubly linked list. Okay, it is a tree node, and let us say doubly linked list. In a doubly linked list, a list node will contain a left, okay, a left and a right. I mean a previous and a next. Previous and a next, not a left right. It contains a previous and a next. So there will be some other node, right? It will also contain a previous and a next. So what we have to do, we have to convert these left rights into previous and left respectively. See, the left of a tree node, okay, the left of a tree node is equivalent to the previous of our list node, and the right of the tree node is equivalent to next of the list node. So this is the data that is given to us, and with the help of this we have to convert this tree, that is BST, to a sorted doubly linked list. Okay, sorted doubly circular linked list. So how we can do that? Let us see how we can do that. So for this suppose what we'll do, we'll take the help of BST property. So what is the property of BST? We all know that in order of BST is sorted, right? Is sorted. So we are going to do this with the help of this property. In order of BST is sorted, with the help of this property we are going to make it a sorted doubly linked list. Okay, sorted doubly circular linked list. And one more thing, you have to do this in place. So what is this in place? What does this in place word means? This in place word means that you don't have to use any extra space. Okay, no extra space. I mean no extra space means no other data structures like array or anything. Okay, you can use recursion, or recursion stack will not be considered as an in place means you don't have to use any other data structures. Okay, you have to use this with the help of in this tree only. Okay, you have to do changes in this tree only, not any other data structure. Okay, so let us see that. So let us see how we are going to do this. Let us move this tree to this side, and we'll try to run this so that we can reach to our required answer. Okay, so our required answer will be one more thing is given in the question, and that is the order of the nodes must be same as the in order, okay, of the binary search tree. And the first node of the in order traversal, that is the leftmost node in BST, must be the head node. Okay, so what it is saying, let's go to the board. It is saying that the order of this doubly circular linked list, that is, see, it is my first node, second, okay, third and fourth. How many? 3, 6, 9, right? 1, 2, 3, 4, 5, 6, 7, 8, and 9 would be this side. Okay, so suppose this is my linked list, and what I have to do, the order should be the in order of this. Okay, that is if we traverse in the in order of this BST, then it would be first one will come, right? One, and after this three, and then we'll have four. So it will be one, then three, okay, and then after that we'll have four, and then after that we'll have six, we'll have seven, and then after seven we'll have eight. After eight we'll have 10. Okay, after 10 we'll have 13, and then 14. So this will be the order. Okay, so this will be the order, and this will be the head. This will be the head node. And to make it circular, this is pointing to this. Okay, and the next of this is pointing to this. Okay, this is how it will be circular. Okay, so what we have to do, let us see that. So I hope that the question statement is now clear. Okay, question statement is now clear, and you know that what we have to do in this question, we have to convert this into the circular linked list, circular doubly linked list, and the required data, which is the data which is given, you already know about that. Okay, so let us start with the strategy that we are going to use. So what we are going to use, we are going to use the in order of BST, right? So how we are going to use it? So first of all, I'll take a dummy node. To which, with the help of which I'm going to create a circular doubly linked list. Okay, circular doubly linked list. We all know what is a dummy node, right? It is a node which we are going to use to make any rest node. Okay, so let us begin. How we can do that? So what I'll do, I will traverse in this tree, and when I will reach to its in order nodes. Okay, or I'll traverse into this tree in order. Okay, in order, and in order, what I'll do, I'll simply add nodes to my dummy. Okay, it is my dummy, and I'll add node 1 because it is the first node in my pre-order, in order, right? So I'll first of all add this. Okay, suppose my previous pointer is here. Okay, I'll take a pointer pre, and my pre is here. Okay, and then after that, after adding this, I'll move this pointer to this. Okay, and then I'll move to this. Okay, and then I'll move to this, and I'll add this one also to my pre-order, I mean to my doubly circular linked list. Okay, I have added this 3 to my circular linked list. Okay, and moved this p to forward. Okay, I mean move this p to this one. Okay, then I'll reach to 6, right? So I'll add the 6. No, I'll not add the 6 because this is not the part of my in order. So I'll reach at 4. 4 is the part of my in order now, so I'll add 4, and after this I'll reach to 6, and then I'll add 6. Okay, and this is moving forward. Okay, this is moving forward. So this is what I'm gonna use. So the question is, how am I going to use this previous pointer, the p pointer that I am using here? How am I going to use it? So for this, what I will do, I'm going to take the help of a global pointer or a static pointer. Okay, I'm going to take a static pointer, or we can say a global pointer. Okay, and with the help of this pointer, we are going to make the pre-order of it, I mean make the traversal of it. Okay, and with this we are going to make our doubly circular linked list. Why I'm taking this global variable, let us see that. So suppose I'll show you with the help of a stack. I'll show you this with the help of a stack. So let me make a stack. This is our stack, and what I'll do, I'll simply keep some let us say random 4k addresses. Okay, these are some addresses: 4k, 2k, 9k, then 7k is the address of my dummy. Okay, it is my dummy, or we can say p. Okay, it is my p, and the address of this is 7k. So what I'm gonna do, I'm gonna show you, if I'll not take a static or global variable, then what will happen. Suppose I'll pass a variable previous in my recursion call. Okay, then what will happen, let us see. So what will happen is, first of all, I'll reach at 8, right? So I'll add 8, will make the left call of 8, and the pointer that will be passed will be this, right? Initially my p will be passed, and p is 7k, because the first pointer that I'm going to add will be added after this p. Okay, and p is initially pointing at dummy. Okay, so that is why I'm doing this. So let us go to the left of this. Okay, so after going to left, we'll reach to 3, we'll make the left call of it, and now also I have my pointer 7k. Okay, and after this I'll reach to 9k. Okay, that means 1. So go to 1, make a left call of it, and then after that 7k will be the address that will be passed as the previous right now. Okay, right now this is it. Okay, this is how it will be done in the stack. And after this we will see that my left is null. So when my left is null, it will do, it will simply return from here. Okay, it will go to right, it will go to the right, and before going right, what it will do, it will attach my previous with this. Okay, so my previous is attached, and after that I'll move my previous to this. Now my previous is here. Okay, now I made a left call. Okay, I made a left call, and after that I made this connection. Okay, but after this my right call is also it will make my right call, and after done with my right call, what it will do, it will simply, okay, now I have not updated my pointer, that is at 9k now. Okay, previous is 9k now, right? After 7k it is 9k, because previous is being moved to 9k. So after this it is done with both calls, right? After it is done with 7, it is done with left call, it is done with right call. So now it will come out of the stack. So when it will come out of the stack, you will see that my previous pointer is again at 7k. It is no more here, it is again at this point. So what will happen here? It has happened that when we pass a pointer into the stack or into the recursion, then the copy of this is sent to the other level. Okay, is sent to the other level, and the changes in the pointer, that is the changes in this passed pointer, will not be persisted when it will come down in the stack. Okay, suppose here it is 7k and here it was 10k, but when this one is erased, then it will again become 7k. Okay, so that is why I need some global variable which will remain same. Okay, which the change in which will be persistent, and I can see the change. The changes that I'll make will not change in each level when I'll come down into the stack. Okay, so that is why I'm using a static variable. So let us start it with the help of a static pointer. So let us do a dry run with the help of that. Okay, so simply it is my dummy node. Okay, and so initially what I'll simply pass this 4k. Okay, now I'll traverse from this. Let's take some other color. It is okay, it is fine. Black is fine. Okay, so I'll start from here. Okay, I'll pass 8 and make the left call of it. Okay, and make the left call of it, and then I'll reach at 3 and will make the left call of it. Then I reach at 1 and make the left call of it. When I make the left call of it, it will say that it is null, so it will come back from there. And what it will do, it will simply make the connection first. Okay, how it will make the connection first? See, it will say what it is saying. It is saying that it has a left pointer, it has a right pointer, right? So it is saying that the left of this that is the point. I'm currently at this point, right? I'm making the connection from this current. So I will say that my left, the left of this current dot left will be pointing to previous. Okay, the left of this will be pointing to previous, and the right will be equals to, the right of it will be equals to the, see, not the right, previous will also have some pointers, right? Previous will also have 2 pointers. So the left of this will be pointing to previous, and previous dot right will be pointing to this current. Okay, so this will happen. So the right of the previous will be pointing to this current, and the left of this current will be pointing to this previous. Okay, so this will happen. So what we will do, let us see. And after that, we are at this, right? We are at this. We are at this stage. That means when we made a call for the left, and after that we'll make the connection first. Okay, so the left of it, that means it is the left, right? So current dot left will be pointing to this previous, that means this, and the right of this will be pointing to this. Okay, so this will happen. And after that I'll move on to, I'll move my previous to this. I'll move my previous to this, but this time my changes will not occur in the stack. These are the global changes. Okay, these are the global changes which will remain throughout same. Okay, which will remain same throughout the code. Okay, so let us move on. And what I'll do after that, right call is done, right? So we move on to, we right call is also done. Suppose after this, after making the connection, it will make the right call, and after right call it will get nothing. So right call is also done, so it will come out this of the stack. And then after that, what it will do, it will simply move on to 3, right? So 3 is done with the left call. So now it is ready to make the connections. So what it will do, it will simply make its left as the previous. Okay, current dot left is previous now, and previous dot right will be equals to this current. Okay, so now this previous will also move on to this. Okay, previous will move on to this. So now it is done with the left call, and it is done with making the connection, so it will make its right call. So now it will move on to right. So in the right we'll get 6. So 6 will say make my left call. 6 will say make my left call. Okay, after making the left call of 6, we'll reach to 4. 4 will say make my left call. Okay, and it will say there is nothing in the left. So what it will do, it will simply, my previous is here only, right? Previous is here only, and my current is here right now. So what it will do, simply it will say, okay, my left is, I'm done with my left. I'll try to go to my right, but before going right, what we will do, we will simply make a connection here. That is the right of this. Okay, this is 3, right? So what we will do, this is current dot left, that means this will point to this previous. Okay, and previous dot right, that means this will move on to this. Okay, this will happen. And then after that what it will do, it will now my current is here, right? My current is here. So it is done with the left call, and it is done with making the connection, so it will make its right call. And after right, it will say I get nothing from the right also, so it will move out of the stack. So it came out of the stack. And then after that, it will reach to 6. 6 is done with its left call. So what 6 is now also ready to make the connection, right? 6 is now also ready to make the connection. So also I'll move my pointer to forward. That means P is here now, and my current is here at 6, right? At 6 my current. So what I'll do, simply I will make the connection. That is the left, this is current, right? So current dot left, that means this will point to previous, and the next of this point to this. Okay, so this is how it will be done. So After that, what it will do, it will also move on this previous to here. Okay, this previous will move on to here, and after this, what it will do, it will see, now it is done with the left call, previous is also moved. Now it will make its right call. It will make its right call, and after making the right call, will reach to 7. So 7 will say make my left call, and from the left call we will get nothing. So it will say okay, make my connections. Okay, so what it will do, my previous is here, so it will break this, and simply will make connection, that is previous current dot left, current is here, right? So current dot left will point to this, and then this will point to this. Okay, in this way it will be, it will move forward. That means this previous is moving to forward now. That means this 7. So previous will move to this. Okay, now after that my previous is here, right? So now I'm going to make my right call, because I'm done with my left call, so I'm going to make my right call. So after making this right call, it will say I'm done with both my calls, take me out of the stack. Okay, and now 6 is also done with both of its call, so take it out of the stack. 3 is also done with both of its call, take it out of the stack. Now my 8 is here, so 8 is done with its left call. So what you have to do, you have to add this, you have to make the connections now. So how you will make the connections, you will simply, your current is here, right? So current dot left, that means this will point to this one, and this will point to this. This will point to this. And then after that, when you will do this, your previous will again move to here. Okay, and after this you will make the right call. That means it is done with the left, it will make its right call. Okay, and after right call will reach to 10. Okay, will reach to 10, and 10 will say make my left call. And when you will make the left call of 10, then you will see that there is nothing in the left call of 10. So you will say that 10 is done with its left call. So now you are going to make the connections, because in order you are making the connection. Okay, so let us make the connections. So here it will be broken, and after this you have to make the bonds. That means here, okay, previous is not moved forward, right? So you have to move previous to here. So what you will do, okay, previous will be there only because we have not moved our previous right now. So this is current, right? So this is current. So what it will do, it will simply make the connections, that is current dot left. That means the left of the current will point to this, and this will point to, okay. So after that, what it will do, it will make its key to this one. Okay, and then it is done with the left call, so it will go to 10 right. Okay, it will go to 10 right. So while making the call for 10 right, 10 will say that I have 14. Okay, so 14 will say make my left call. So after making the left call of 14, we'll get 13. Okay, so 13 will say make my left call. So after making the left call of 13, we'll get null here. Okay, there is nothing, so we get null here. So when we get null here, we'll return from here, right? And after that, what we will do, we'll simply make the connections, because it is done with the left work. So we are going to make the connections now. So this connection will be made, that is this 13 will be added to this. In which way? In the way the left of this is previous, right? So previous dot right will be this, and the left will be going to this. Okay, so this is how it will be. And then after that, we are at 13, so we'll move this to 13, that is previous will move to 13. So previous will come here. Okay, and 13 is done with the left call. Okay, and it is also done with making the connection, so it will now make its right call. From the right call, we'll see that it has nothing in the right. So what it will do, it will come out of the stack. So here it will come out of the stack, and then after that we'll reach to 14. Left is 14 is done with its left, right? So now when it is done with it left, so it will do its right work. That means now we are going to make the connection with 13 and 14. Okay, current is here, right? So now my current dot left, that means current dot left will point to this and the right will point to this. Okay, so now it will happen, and after this what we are going to do, we are going to move our previous to this. We are going to move our previous to this. Okay, so now I'm done with my 14 right. I'm done with 14 left. I'm done with making the connection, so I'll make my 14 right. Okay, and after making 14 right, it will get nothing as there is null in the 14 right, so it will come out of the stack as it is 14 is done with both of its call. Okay, and then after that 10 is also done with both of its calls, so it will come out of the stack, and 8 is also done with both of its calls, so it will also come out of the stack, and in this way the stack will be empty. Okay, and when the stack will be empty, this program will stop, right? This program will stop, but what you have to do is you have to make this as the head. Right now this is head, this is head. Right now let us not write these addresses now because no need for this addresses now. So right now my dummy is pointing toward the head because see, okay, this is not broken, so it will also break, and any other link. Okay, so this is my simple and beautiful doubly linked list. Okay, now this is pointing to my head. Okay, this is my head right now, but I have to make this as the head. So what should I do? I'll simply do d will go to d dot next. Okay, and also I have to do one more thing, that is I have to break this bond. I have to break this bond also. So what I'll do, I'll say I'll take a temp and I'll move this temp to temp dot next. I'll point this temp to here. Okay, first of all I'll point this temp to here. I'll move this temp to here. Okay, and what I'll do, I'll make its left, that is temp dot left, or we can say temp dot previous. Okay, not previous because it is still a tree node just converted to a linked list. It is still a tree node which is converted to a linked list, doubly linked list. Okay, so temp dot left will be equals to null, and I'll make it equal to null, and after that what I'll do, I will make this one also null. That means left is equals to null, and this is at this is at d, right? So d dot next will also be equals to null. Okay, so this is what I will do. So let us go and write the code for it. Okay, because we know how to do the dry run, right? So we already have this dry run, and now we get insight of this code. Okay, we get the insight of this code. We are going to use the static word, or I mean the static pointer, or a global pointer we can say, and that will move to one pointer to other. Okay, that will move to one node to other in order. In order we are going to do the work, we know that. So let us try to write. So let us look into the code of it. Okay, so we are going to code in Java, so let us do the code. So what we are going to do first of all, we need a previous, right? We need a static previous. So we'll do private static node previous equals to null. Okay, it will be pointing to the null. First of all, it is a static pointer, and we also need a helper function. That means private static, it will be void type, void b to dll helper we can say. Okay, and we'll pass the root in it. So node root. Okay, now the function, the logic that we have decided was we will go to left, we'll do our work. Okay, try to convert it into the circular linked list. Okay, I mean the doubly circular linked list, and then after that, okay, first of all, the circular thing we are not going in the recursion. We are going to do that in the end. So with the help of the recursion, we were just converting it to a doubly linked list. Okay, we all know that in the end, I mean in the starting, what we were doing, we were just adding these, right? We were just adding these connections, and but in the end we were shifting this to this, the head to this, and after that we were making connection of these two, okay, of this head and this previous. Okay, so let us go back. So what was our logic? Our logic was we'll go to left b to dll helper, okay, and we'll call root dot right, root dot left, okay, and here we'll do some work, and then b2 dll helper will pass root dot left, I mean root dot right, okay. But here we need to do something. What we need to do, we are going to do this previous dot right. In previous dot right we are going to put our root, okay, because our current is root, right? Previous dot right will be equal to current, and current will be, I mean root dot left, current dot left will be equal to previous, and also need to shift the previous, so previous will be equals to root, okay, previous will move to root now. And in this way it will be converted to a doubly linked list, okay. And now one more thing is remaining, that is base case. So what we are doing at the time of, if root is equals to null, and at this time we were simply returning from there, okay. So it will help me to convert my BST to my doubly linked list. And after that, in this, what I will do, I'll simply make a dummy node. So node dummy is equals to new node, okay, and this will be -1. And after this, what I will do, simply take a previous, I mean previous equals to dummy, okay, previous will point to dummy initially, and then after that what I will do, I will make b to dll helper call, okay. I'll call this with the help of root, okay. So what it will do, it will add my previous to my it will add my linked list to my previous, okay. That means it will give me the it will give me the doubly linked list, okay. And my head is previous, and my head is dummy now, okay, because previous will move to end in the end, right? So in the end previous is here, so my head right now is this dummy, okay. So we'll make a head, that means node head is equals to, head will be equals to dummy dot next, dummy dot not next, it will be right, okay, dummy dot right. So and after that what it will do, it will simply do this, that is dummy dot right, dummy at that point only, right? Dummy is at that point only. That means what I'm doing, see, it is my dummy which is pointing to some nodes, it is my dummy, okay. So what I'm saying that I'll take a head at this, okay, with my previous will move in the end right now, is at the end right now. So I'm saying that I'll take my head at dummy node head is equals to dummy dot right. So at dummy dot right, that means at this I'll take my head, okay, and my head at this now. So what I will do now, I will do dummy dot right, that means dummy dot right, that means this link will equals to null. Now this will point to null, and this also, this means head dot left also will become null, okay. So let us do that. Dummy dot right equals to null, and dummy dot left is equals to null, okay. I mean not dummy, it is head dot left, okay. So head dot left and dummy dot right will be null. So after that we have a linked list, a doubly linked list from head to previous, okay. From head to previous we have a doubly linked list, but we don't have to make a doubly linked list, we have to make it a circular doubly linked list. So what I'll do to make it circular, we just have to do one thing, that is head will point to, see, my previous is pointing to right, so previous is this, so previous will point to this head. So previous dot right is equals to this head, and this head dot left will point to head dot left will point to my previous. Just this is what you need to do, and then from there you can return your tree node, that is return head. Okay, so I hope that this is done. So we'll simply give it a run to check if it is running or if there is some compilation error or not. So let us give it a run. Okay, accepted. Let us give it a final submit for all the test cases. Code is accepted. So I hope that you got this code completely. Okay, there are some other ways also with the help of which we are going to solve this. Okay, we'll see in some next video after this, and until then, goodbye, and don't forget to like the video and subscribe the channel, and also share it with your friends. So that's all for this video. We'll meet in the next video now. So goodbye.